encryption. Actually, there are two types of encryption, guys. One is symmetric encryption. Okay. Okay, and other one is asymmetric. Okay. Whatever the spelling. So actually what it does in the symmetric encryption, this is also called a block cipher. Okay. What is block cipher? I will explain that. Block cipher. Symmetric one. And this is called a stream cipher. Stream cipher. Example is RC4, RSA. I will explain those are things. So symmetric is what, guys? It's like there is a router 1, there is a router 2, suppose. Okay, R1 and R2. What happened actually in symmetric encryption, there is a one key. Okay, there are one key and both are they are using a one key, but both are using a one key, one single key. Both have one key. So both actually router 1 and router 2 both have one key, and they're using the same key. They're using the same key for what? For encryption and decryption the packet. Okay, encryption and encrypt or decryption the packet. So with the help of whatever, like if this router 1 want to encrypt anything, he will use this key and it will encrypt the packet, then forward to the R2. Then with the help of, and it is also has a one key. With this one key, it will decrypt this packet. Whatever the encryption packet come, it will decrypt this packet. Okay, and when it has to forward any packet, it will, with the help of same key, it will encrypt the packet and then forward to the peer 1. Okay, the same one key, both have a one key only. With the help of one key, both encrypting and decrypting the packet. Simple. Asymmetric, the same thing, guys. They're actually using a two key. Yeah, they are using a two key. Okay, they're using two keys. What are two keys? One is private key. Other one is public key. So what happened, guys? Both are using two key. So like router 1, what both does, it has a how many key? Two key. So it will put his private key. Okay, it will keep his private private. It will keep his private key and forward his public key to this guy. Okay, and the same way router 2, it will keep his private key and forward his, I'm writing a public, and forward his public key to his peer. So both actually keeping his private key, okay, and forwarding his public key to the other peer. Got it? Why it is do so? Why? Because if this PC, this router, if he has to be encrypt anything, if he has to be encrypt any packet, what he will do is, if he has to encrypt, he will, with his private key, he will encrypt the packet with his private key, because he is the initiator now. So he is use his own private key to encrypt the packet and forward to the peer, whatever the packet is coming. So whatever the packet is coming encrypted, now router 2, actually router 1 uses his private key for encrypting the packet. Then router 2 will use, okay, guys, tell me, router 2 has a how many key? A two key. One his private key, other one peer
R1 public key.
Router 1, router 2. So what it does, so it both have a two key. One is on public key. On means myself, or he's on private key. Sorry, on private key. And second is peer public key. It has a on private key and peer public key. Private key they are using, that's why its name is public key, because they will public it, they will forward to the peer. So okay, peer public key. So any packet, if R1 is forwarding, any packet forwarding by any router. So for any, like, who is forwarding the packet, it will use his own private key, for what? For encrypting the packet. Always remember, for encrypting the packet. So it is using public key to forwarding, encrypting the packet, and then it will forward the packet to this guy. Okay. Then this guy will use, okay, then this guy will use his own private key to decrypt the packet. Then if he has to be encrypt any packet for the R1, he will use their public key to encrypt the packet and then forward the packet. Okay, so that's how actually it's called asymmetric. So now come what is symmetric and asymmetric. Okay, so symmetric encryption, it means both are having one key. The example of symmetric encryption is called block cipher. Okay, what is block cipher? Example of block cipher is DES, 3DES, and AES. Okay, DES means what? Data encryption system, and 3DS is what? The same thing. Whatever the DES is there, it will just do the 3 times. That's it. Okay, so this is actually the 3 things. They are called block cipher. What is the meaning of block cipher? You take a like 64 bit, okay, any 4 bit, okay, 64 bit, 56 bit of any like some bit of packets, and it will encrypt it. Then once it encrypted it, encryption means what? It will generate some alphanumeric character. So in the DES, what it does, it will take a 6 bit of packet and it will encrypt it. And once it will encrypt, it will generate a 64 bit of encryption packet. Okay. So then once the 56 bit of packet done, then again it will take a 56 bit of packet and then it will encrypt the 64 bit of packet. So that is why it's called block cipher. It is taking a block, some bit of block size of data and encrypted it. What is asymmetric? Asymmetric means is a stream cipher. Stream cipher means it is example of RSA, 1 bit to 1 bit. And its example is RSA, RC4, even the DH. These are the example of asymmetric encryptions. What it does, it will do like it will take a 1 bit of data and encrypt it. Then again, it will take a 1 bit of data and encrypt it. It will take a 1 bit of data and encrypt it. That is called stream cipher. So this is RSA, RC4, and DH is an example of asymmetric. So guys, now you know what is symmetric and asymmetric. What is DES, 3DES, AES. Okay, let me explain some more DES. So DES, what I explained, what it does, guys, it will take us some 56 of 56 bit of packet. Okay, and it will encrypt it and generate a 64 bit of alphanumeric encryption value. Like it is compromised, guys. Okay, no one using. In the 1970, actually, IBM has introduced DES. Okay, so now once it is compromised, okay, and once it is compromised by the hacker, they have using the same things but just multiplying to 3 DES. Means it is taking the 56 bit of data only, but it is encrypted the 64 into 3. How much, guys? Calculate it. So it will generate a 192 bit of packet. So it is actually strong, but it is also going to be compromised. Okay. Then again, it came AES, Advanced Encryption System. Okay. So AES is actually like a AES. It has some kind of AES 192, AES. So these are AES is actually using nowadays, and it is not, it's a very advanced level, it is not compromised. So these are all encryption method, guys. Okay, encryption method is using for encrypting the packet. Okay, I want to explain hashing. Hashing is what, guys? Hashing is the same thing, integrity, which we have explained, integrity. Same thing I have already explained. The MD5 and SHA is the example of integrity. Those are actually able to provide authentication. Okay. So we have already learned what is MD5 and SHA, right? No one can tamper your packet. Okay. Now there is one Diffie-Hellman also. Okay, DH, Diffie-Hellman. So this is also actually in the 1975 something. There is some Diffie-Hellman. Hellman is a like teacher. Diffie is his student. Both are create one some encryption method actually. Actually, that is actually using some nonce, okay, and some values that over is actually helping to share a packet. Okay, like this is a router, whatever. It is actually to share a key, to share a key over the ISP, to share the key over the ISP. Defi element is actually helping to share the key over the ISP. Okay, and it is actually with the help of nonce. Nonce is same like an anti-replay mechanism. Okay, which I explained it. Okay, so it is actually sharing the key and provide the security of the key over the ISP. And it is actually like, what is key, guys? Key means what? Like I have typed Cisco. Like we have typed some kind of a password, right? The same actually password. They are actually sharing both sides, and then they have, with the helping of password, they have generated their own key. Okay, so that is actually Defi element is only helping to sharing the key over the ISP. Okay. Now, guys, now it's came IKE. IK is what, guys? Internet Key Exchange. Exchange. So, guys, Internet Key Exchange also we can use to say Isaac MP. Okay. Isaac MP is what called Internet Security Association So, guys, if you one or one, both are okay. One is aggressive mode. Fine, guys. Note it down. Aggressive mode. Fine. Okay. What is main mode, guys? I want to explain main mode, guys. Then aggressive mode, and then wheels. So that, guys, suppose there is a one router. What is main mode, guys? I want to explain main mode, guys. Then aggressive mode, and then wheels. So that, guys, suppose there is a one router, and there is a one router, and I'm going to terminate the VPN over there. Fine. This is R1, this is R2. Okay. So for main mode, there is actually a 6 packet exchange for creating a VPN. For creating a VPN for IKE phase 1 or IPsec phase 1, IKE phase 1, there's a two things, main mode and aggressive mode. In the main mode, there are 6 packet exchange. What is those 6 packet exchange? So there is a one initiator. So like this one is initiator. Okay. And this one is responder. What happened in the first packet? This router one will forward his all policy detail, policy parameter. It will forward his all policy parameter. Okay. What policy parameter? It will forward his encryption method. Which encryption method I'm going to use? Like he's going to use AES. Which hashing method I'm going to use? So like hashing method, he's going to use SHA. Okay. Then like which Defi element I'm going to use. So Defi element is actually calling as a group 1, group 2. So, okay. So whatever the higher group you will use, that is what much secure. Like he's going to use group 2. Okay. And there is a which authentication method I'm going to use. There's a two kind of authentication method. One is pre-shared. Okay. And other one is digital. If there is any third party of digital certification. So I'm using pre-share all the time. Okay. Pre-share. So these are the policy, and there's a lifetime. So lifetime is actually by default, or they're using 24 hours. Okay. So that is just keep it like this. 24 hours they're using by default. So these only information, this is a policy parameter. It is passed from packet number 1. Okay. In the second packet, my responder will respond to its own it's their policy parameter. So guys, make sure both policy parameters should be same. Both policy parameter, both side policy parameters should be same, right? If there is any mismatch, if you are using AES, this router using AES encryption and this router using some DES or 3DS, it is not going to be used. It's not going to be VPN. VPN not going to be configured. Okay. Both sides, the same configuration need to be done. Got it, guys? Otherwise, there would be a no VPN configuration. Both side policy parameters should be same. In the third packet, initiator will share his key with the help of Diffie Hellman. It will share his key with the help of Diffie Hellman. Shared its key with the help of Diffie Hellman. So Diffie Hellman actually here, Diffie Hellman is actually sharing the key with over the ISP. And the fourth packet, this router 2 will share his key over with the help of Diffie Hellman, the same packet. Okay, same packet. Now the Diffie Hellman key has been exchanged. Okay, the key has been exchanged. Now the fifth packet is, guys, till 1, 2, 3, 4. This packet is plain text. Now the key has been exchanged. So fifth packet is an encrypted packet. Always remember. So in the fifth packet, router 1 or initiator forward his signature ID. Okay, signature ID. Then hashing certificate. Okay, and IP address details, whatever the IP address. Okay, IP address details. These information has been forwarded by the fifth packet, and in the sixth packet, the same information provided by the signature ID, hashing certificate, and IP address by the responder. So these are the 6 packets, and these are the encrypted packet, guys. Encrypted packet. This packet is also, this router 2 will forward his own signature ID, hashing certificate, and IP addresses. Okay. So first 3 and 5 will forward by the initiator, router 1, and second, 4th, and 6th forward by the R2. The same copy packet. Okay. So once the key will be exchanged, the 5th and 6th packet will be the encrypted packet. Remember. So these are the actually a policy parameter exchanged by the mainboard. Got it? Once this packet exchange done, then there would be a IKE phase 2. Well, it means the phase 1 has been created. Then there is a IKE phase 2. In IKE phase 2 called quick mode. Okay. Before going to quick mode, guys, I want to explain one more mode. There is in the phase 1, there is a one more mode called aggressive mode. Okay, aggressive mode. Aggressive mode is actually a less secure, and main mode is actually a more secure. Aggressive mode, there is a 3 packet exchange. Okay, the same thing. Like if you don't want to use main mode, you will use a aggressive mode. Okay, because phase 1 there is a 2 mode. Okay, either use main mode, either use aggressive mode. So aggressive mode, very few are using. It is little bit fast. Why? Because only there are 3 packet exchange. What it does in the 3 packet exchange? In the first packet, it will forward all his policy parameter, his all Diffie Hellman key, all signature ID, everything. Everything it will forward. Like, okay. And the second parameter, like router 1 will forward. Okay. Router 1 will forward all its policy parameter, whatever in there. Okay. So like whatever the fourth, third, and fifth packet, right? It will send in the first packet only. And the reply, the responder 1, in the second packet, it will send his all policy parameter, all Diffie Hellman key, and also the hashing certificate, IP, everything. So in the one packet, it will forward everything both sides. And third packet is for the initiator will forward his acknowledgement packet. Acknowledge. Okay, I will got his all the information and its match. Acknowledge packet. Only these 3 packets. So this is actually a less secure. It is not secure. It is very much less secure. Okay, but it is fast because only it is a 3 packet. It's a fast actually, but less secure because it's a 3 packet exchange. So that is what aggressive mode, and this is what main mode. Now this is quick mode. So one phase 1 done, there is a phase 2 called quick mode. In the quick mode, also a 3 packet exchange. Okay. So what happened in the quick mode? There actually, see, main mode is actually for the creating a like a path tunnel. It's creating the phase 1 tunnel. Once the main mode done, it is actually creating the path for tunnel. Okay, tunnel for the path. Why path? It means this is a pathway. Okay, it will create a tunnel for the path from where the packet would be passing. Okay, and phase 2 is for whatever the data is going for security of my data. Security of my data. Whatever the data is going, just for the security of my data. Understood the difference? Phase 1 is a tunnel for the way. Security of the way. Tunnel is only for the this. It will create a tunnel for the. Actually, it's not a tunnel kind of stuff, but it's the outer layer. Yes, it's a tunnel. That's why it's called tunnel. This for the whatever from where the way, the road, I used to say, the way from where the data will be passing, that is the tunnel is for the phase 1. Now, if the packet is going through that from this tunnel, the phase 2, it is for the securing the data. Phase 2 is for the securing the data. Phase 1 is not for securing the data. Phase 1 is for the securing the way, securing the road, okay, from where the traffic would pass. Phase 2 is for the securing the data. So in the phase 2, there's a 3 packet exchange. So first packet, what it is does, okay guys, one thing I want to explain, I think I forgot. What is encapsulation, guys? Encapsulation means, guys, like, it's kind of a container, and putting everything in a standard way in a one container, it's called encapsulation. So how we are providing the security of a data is can be defined into the quick mode or phase 2. So there actually it will provide the which we can use ESP or AH, whatever. So ESP is actually providing the CIA method. I'm using HP. So which encryption method I'm going to use for encapsulation, ESP, and which hashing method I'm going to use for encapsulation. Okay. So this is actually the first packet would be from initiator to responder, and second packet will from the initiator, from responder to the initiator is the first. This is also it will also provide his which encapsulation method they are going to use for encryption, and which encapsulation method they are going to use for hashing. So this is these two packet, the same two packet. Okay, they are sharing from packet 1 and packet 3. The third packet is for the acknowledged packet from the initiator to the responder. It's the acknowledged packet. Only these two actually the most thing. Which encryption method we are using for the encapsulation, and which hashing method we are going to use for the encapsulation. Okay, this is the only things, guys. If you want to use Diffie element, you can, but it is optional. Okay, it's optional. Okay, so these are the only 3 packet has been exchanged for the quick mode. Once it's done, it means our tunnel for the phase 1 and phase 2 is completed. Now my VPN would be successfully terminated from the both sides. Once your phase 2 is up, my VPN is successfully terminated. Now we can able to forward the packet, and it is successfully passing through. Okay,